Hello viewers, welcome to Academito. In this video, I am going to discuss an introduction into Cisco Packet Tracer and implementation of simple local area network using CPT, that is Cisco Packet Tracer. To download this application software, the link has been provided in the description section. So please download according to your requirement. Before watching this video, please do watch the OSI model and the IP address videos in the computer networks playlist. Welcome to the world of Cisco Packet Tracer, a powerful network simulation tool that helps you to design, configure, and troubleshoot complex networks, whether you are a beginner learning the fundamentals of the network or an advanced user experimenting with new network designs. So Packet Tracer is the perfect tool to enhance your skills. Developed by Cisco, the Packet Tracer provides a realistic simulation of network environments, enabling you to create and interact with various devices such as routers, switches, personal computers, laptops, and more, all within a virtual space. So now what you are seeing on the screen, that is this front view of Cisco Packet Tracer, the latest version I installed, that is Cisco Packet Tracer 8.30 version. So here where the white space is available, this is called as the logical space where you can create your network. And coming to the bottom right left corner, you can see the network devices. Here you can see network devices. So router, switches, hubs, wireless devices, and the security, and also WAN simulation. So these are the network devices are available in Packet Tracer. Coming to the end devices, we have different types of end devices here: personal computer, laptop, server, printer, IP phone, voice over IP device, and phone, TV, wireless tablet, smart device, generic wireless, generic wired, and the sniffer. So these are the end devices, and the network devices are available in Cisco Packet Tracer. You can explore them. You can do the complex networks design and configuration. You can observe the output in two methods here. So in the right bottom corner, you can see there are two options here: real time mode and the simulation mode. You can observe the output, that is behavior of the network, in two modes, that is real time mode and the simulation mode. Real time mode means through the command you are going to observe the output in real time mode. So by using the user interface, you are going to observe the output. So continuously you are going to explore this Cisco Packet Tracer. So now in this video, so I'm going to discuss about how to implement the simple local area network. Okay, so before designing any network here, okay, so first of all you have to understand about the addresses. The last video we are discussed about the IP addresses. Please go through that IP addresses. So in this, first you have to build the topology. So after building the topology, so next you have to assign the IP addresses. If any designs are there, first you have to do that designing part. For example, if you are doing a virtual LAN, so then you have to complete the command detail section, then topology. So then the address of assigning the IP addresses, then the configuration, then you have to see the output in real mode or the simulation mode, like that. So now here I'm going to create the simple LAN. Okay, so for that, first I'll discuss about the topology. So here what I'll do, so local area network means, so it will be It contains a simple switch here, simple switch. So this is the simple switch. So to this switch, I am going to connect 3 PCs. So let us say this is PC0, PC1 and PC2. And these are the transmission media. These are the connections. So the cable I used here, these are called as the connections. Okay. So where these connections are available in packet tracer. So just I'll come to packet tracer now. So on the left bottom corner, you can see the connection symbol here, the red symbol. If you click that, you can see various transmission medias are available. So very frequently used transmission medias are copper straight through cable and also copper crossover cable and also serial DCE cable. So these 3 transmission medias we are going to use it. It's available exactly at the left bottom corner. Okay. Now coming to topology is designed here. This is one network. Okay, so this is one network here. So we don't know the address of this network. This is one network. Okay, so now I'll decide to take any IP address from class C. Okay, so you know class C starts with 192. So I'll choose this IP address 192.168.1.1. So I want to give it to this PC0. So this PC IP address will be, so I'll choose this 192.168.1.1, and for this PC I'm going to choose the IP address 192.168.1.2, and for this IP PC I'm going to choose 192.168.1.3. So how many IPs I can choose in this network? What is the starting address? What is the ending address? So how we are going to find that? So for that you should know how to find out the starting address, first address. What is the first address? That is the network address. Okay. So in the last video I have discussed how to find out the network address for this kind of IPs. Okay. So this is a class C IP address. You know only the last octet is reserved for host. And next first 3 will be reserved for network. This is for network and this is network and this will be network. So 24 bits are reserved for network, rest of all 8 bits are reserved for host. So now if you make this host part as 0, I'll get the first address 192.168.1.0. This is the first address. So this address is nothing but your network address. Okay, and next increment this last octet by 1, then I'll get the first address, valid address 192. So next IP will be 192.168.1.2. So it goes up to the last address 1.255. Okay, and the first address will be the network address and the last address will be your broadcast address. So these 2 IP address you can't give it to any end devices. Okay, and previous to the broadcast IP address will be this 192.168.1.254. So that means that with the valid IPs are 1 to 254. These are the valid range that you can assign to any end devices I'm talking about. Okay, or end devices are for the network devices. Okay, or maybe router. So the first address, that is the network address, and this broadcast address, you can't give it to any end devices or the network devices. So you have to keep it in mind. So these are the, so in this network I can connect totally 254 systems for this switch. Okay, so one switch will be having 48 ports or 28 ports. So what are ports? So these are the interfaces. Here you can see where you are going to connect here. So these are called as the ports or the interfaces. Usually it will be fast Ethernet 0/0. Okay, or it may be gigabit Ethernet 0/0, like that. This is called as the interface. So in this way, first you have to choose the proper IP addresses. That's very important. So without that IP address, you can't communicate with each other. You should know it. What are the valid IP addresses? You can give it to the end system or the network devices. So for that, you should understand the class A, class B, class C thoroughly. That's very important. So now I'll go to construct this same topology using packet tracer. So now first I want switch. I'll go to the network device. I'll click on switch. So here 2960 switch is available. So just drag and drop it here. So just place a cursor on this switch. See, it shows 24 interfaces are available. That means that for this switch you can connect 24 systems plus, followed by 2 gigabit Ethernet ports are available, plus 2 systems also you can connect. So totally 26 systems you can connect it. MAC addresses are also displayed here, that we'll discuss later. So this is the switch I have taken. So next I'll want 3 PCs. I'll go for end devices, then I'll go to PC. I'll place 3 PCs here. First PC, PC0, PC1, PC2. So next, coming to the connections, I'll click on the connection. I'll make use of this copper straight through cable within a network. So just click on that, select fast Ethernet 0 from the PC and click on this switch and select fast Ethernet 0 port. So like this you are going to connect it. So 3 systems are connected to this switch. So now I want to label it. Okay, so I want to know what are the IP addresses given to which system and all. Okay, so I want to label it. How to do that? So just go here above this physical option. So there is an option called place note. Okay, click on that and you click here. So it will give me the dialog box where you can type like a text box. So I'll type the IP address 1.1. Next 192.168.1.2. Next third IP 192.168.1.3. This is the IP address I'm going to assign it. So just I label it. So now how to assign the IP address? It's very simple. Click on the PC0. There you'll get so many options here: physical, config, desktop, programming, attributes. Next go to the desktop. Here go to IP configuration. So here you can see 2 types of IPs are available. IP configurations are available: DHCP and static. Now we'll see what is static IP address. So now I'll assign 192.168.1.2. 1.1. So as soon as I click at the subnet mask will be generated. So what is the subnet mask? So coming back to this IP selection here. So now I selected class C IP address. Okay. So 192.168.1.1. So as I said, for class C, 24 bits are reserved for network. Okay. So here network means bit 1, host means bit 0. Okay. So 24 bits are reserved for network means here 8 ones. First octet will be 8 ones. So 4 plus 4. So then 8 ones. And next 8 ones. Followed by 8 zeros. This is the last octet. Seven, 8. Okay. Now I assign the IP address here. Just you can see, I'm going to assign the IP address. So just I'll close this window. I'll place the cursor on this PC0. So it's showing here fast Ethernet 0, 192.168.1.1/24. Okay. What is the /24? Number of network bits. This is also called as prefix length of the IP. So this is also called as the prefix length. So here 24 bits are reserved here. This is 8 bits, 8 ones, 8 ones, and the 8 ones. That's why it's showing as /24. 1.1/24. This is called as the prefix length. So this indicates how many bits are reserved for network. So here if you convert into the decimal part, it becomes, this is 255 and this 8 ones, and here 8 ones, this is 255 and this is 255 and this will be 0. So that's why the subnet mask is generated as 255.255.255.0. This is generated. So next you can assign your own subnet mask, that is called as, that comes in the subnetting. If you borrow any number of bits from the host part, for example, if you want to borrow these 3 bits from the host part to design a network, 1 2 3 bits, then it becomes 24 plus 3, 27. Then it shows as 27. So what is this value? See, this is 128, 2 raised to 7, this is plus 2 raised to 6 plus 2 raised to 5. So 128 plus 64 plus 32. This is the value. So then subnet mask becomes 255.255.255. So this summation value. Okay, that concept is different. We'll see in the upcoming videos how to do that subnetting and all. So this you have to understand, what is the subnet mask. Okay, how the subnet mask will be generated. This is for class C. So for class A, if you can see for class A, so only the 8 bits are reserved for network. Then the subnet mask becomes 255, then 255.0.0.0. For class B, 255.255.0.0. This is for class A, and this is for class B. Class C will be, so obviously 3 octets are reserved, 255.0. These are the default subnet mask I am talking about. These are called as the default subnet mask. You should know it. What is the meaning of subnet mask? Slowly we'll see what is the significance of this subnet mask, why it's needed and all. Okay. So this is about the subnet mask, this generated here. So now I'm going to assign the IP address for PC1 also. Go to click on that PC1, go to desktop, go to IP configuration, select the static. Okay, assign the IP address. So 192.168.1.2. Just I click on the subnet mask, it will going to generate 255.255.255.0. Close this. I'll go to PC2, desktop, go to IP configuration, static. So then 192.168.1.3. So then subnet mask will be generated. So now you can see the IP addresses are assigned. This is 1.1/24 and this is 1.2/24 and this will be 1.3/24. So three IP addresses are assigned. So now I want to make communication between this PC0 and PC2. So how to observe that? I can observe in real time, that is real time mode and the simulation mode. Okay. So first we'll see how this switch identifies all these devices like PC0, PC1 and PC2. This switch device comes in the data link layer. In data link layer, the address will be the MAC address. So switch identifies the host machine through the MAC address. Okay, so that is very important here. Okay, then how to see the MAC table of a switch? So just click on the switch. So then go to CLI, command line interface. Okay, so then press enter key. So you will be on the switch prompt. Okay, so now you are in. So after entering to the switch CLI, okay, so it shows like this, switch prompt. So you should keep it in mind that any networking devices, router, switch, any networking devices works in two modes. One is privileged mode, second one is configuration mode. Okay, I repeat, networking devices works in two modes. One is privileged mode, second one is configuration mode. So in privileged mode, how to enter into the privileged mode? So now we are in switch prompt. Just type the command enable, then press the enter key. It will take you to privileged mode. It will be like switch hash. So I'll do it here. So just I'll type enable, switch hash. So now you are in privileged mode. So now first time I am visiting to this privileged mode, I don't know what are the commands are available. So then how I'll come to know what are the commands are available? Just type the question mark. It shows what are the commands are available, what is the significance of each command. So everything will be displayed here. Okay. So now here I'll see about the show command. Okay. Show command. I want to check this show command. Under this show command, so what are the commands that are available? Again, you have to give show question mark. So space question mark. So if you give that under the show command, what are the sub commands are available with respect to the prefix called show? Okay. So now I am concentrating on the MAC address table. So just you can see, so there is a command called MAC address table here, this command. So now I'll type that command. So show MAC address table. This is the command. So I think there is an error in the command. Let me see. So MAC address, MAC address table. This is the command. So now we can show here. Now we can see. So here MAC address tables are available in this VLAN means virtual LAN 1. So that is fast Ethernet 0/2 and fast Ethernet 0/3. So both are available. Okay, but I connected three systems, so it's not showing the another IP address. Sorry, the MAC address. Okay, so for that you have to make the communication between the all the systems. Okay, so it's showing the MAC address of this 0/2 fast Ethernet 0/2. So here it shows the interfaces here. So just I'll drag it here. See here, this is fast Ethernet 0/1 and this is fast Ethernet 0/2 interface, and last one will be fast Ethernet 0/3, this one. So it's showing the MAC address of this one and this one. It's not showing this PC0. So first we'll see how to observe the output in real mode, real time. Okay, now I am in real time. What I'll do, I'll try to make the traffic, that is I try to make the communication between this PC0 and this PC2. Okay, so PC0 address will be this and PC2 address is 1.3. So just I'll click on this PC0, I'll go to the desktop, then come to the command prompt. Okay, now I'll give the command ping, P-I-N-G, ping the destination IP, that is 192.168.1.3. So just I'll press enter key. So I'm getting a message reply from 192.168.1.3. So how many bytes? So it just a and also time to leave. So this some information I got it from the 192.168.1.3. Okay. So here you are going to see the how communication is happening in real mode using the command ping. Okay. And if you want to observe the output in simulation mode, just go to simulation. Here you can see simulation panel is available. So here at the right bottom corner there is an arrow. So just click that arrow, you will get a simulation dialog box here, something like new, delete, toggle PDU, something is there. Okay, so in simulation mode what I'll do, I'll drop a packet, a frame from PC0 to PC3. So here at the right top, here you can see add simple PDU, protocol data unit. In the OSI model video, I discussed about this protocol data unit. In application layer, it's called as the user data, that is user message. As soon as it comes to the present layer, it becomes the formatted data. In session layer also formatted data. In transport layer, it's called as segments. In network layer, it's called as packets. In data link layer, it's called as frames. And physical layer, that will be bits. So here I'll take one PDU. I'll drop it from here. This is the source and this will be the destination. Now I'll play this simulation button. See, now first it transferring to switch. So from switch is directly transferring to PC2 because switch already updated the MAC address. So PC2 sending the acknowledgement also. So in the real time simulation panel, see, I'm getting successful message here. Okay, so that means that you are able to send the data between PC0 and PC2. So now how to check the OSI model here, that's very important. Okay, so now here in the simulation panel you can see there are 4 options here. So visible, time, last device, at device, type. So first the communication starts from PC0, then data will go from PC0 to switch, then it goes to switch to PC2, then PC2 to switch 0, so then switch 0 to PC0. Then the communication ends the PC0 by receiving the acknowledgement. So these are the protocol used ICMP protocol. Okay, so we'll discuss about the protocol in detail later. So now if I click on this colored button, that is colored button here, if I click on this box, so it shows me the protocol data unit information. Okay, so now that communication happening between PC0 and switch 0. Switch is a data link layer device. Okay, so now it's showing the MAC address, from which MAC address you want to send the data. It's showing layer 1 and layer 2. This is the physical layer, port Ethernet address, and layer 2 will be the data link layer. It's showing the Ethernet MAC address. Okay, just clicking on this video, you can get all the information. So here inbound video is also there. Here you can see in detail about the what is Ethernet frame look like here, preamble, destination address, source address, data available. Okay, so that this is the next will be the IP data format. Okay, we are using IP version 4, IPv4. The size of IPv4 will be 32 bits. So here you can see it has been divided 0, 4, 8, 16, 20, 24, totally the 32. This is the IPv4 data format. It contains some information here. Here you can see source IP is 192.168.1.1 and destination IP will be 192.168.1.3. So I'm sending the data from 1.1 to 1.3. So next ICMP format also you can see here, and also what is the variable size length of the data, that also you can see. And also this is inbound packet data protocol data unit, and this is outbound protocol data unit. Okay, so in detail information you can get it using this Cisco packet tracer. Packet details also you can get it, and also layers details, in each layer what's happening, information, all the information you can see it in a realistic fashion. So that's why it's called, I say, it's a very famous tool to learn more about the networking. Okay, so in this way you can observe the output in real mode and the simulation mode. So in this way you can construct a simple LAN using the Cisco packet tracer. So this is the, you can say, the introduction about the Cisco packet tracer. Any doubts, please comment on the comment section. Thank you for watching. Please do subscribe the channel.